Hello, dear students. So let us begin our course on logic and sets, which is your SEC paper. That is a skill enhancement course aimed at enhancing your mathematical skills. So there are two options actually: logic and sets and programming in C. But because it doesn't have practical, SEC doesn't have practical, so we decided not to go with programming in C, because programming without your that is practicals is meaningless, right? So let us begin the chapter on logic and sets. So it's a very important concept in mathematics, and it is required in all in whatever mathematics you do. Mathematics is just a poetry of logical ideas, okay? Implications, quantifiers, right? Universal and existential quantifiers, truth values, right? Statements and all, okay? So I'll be following the book by Goodyear, Discrete Mathematics by Goodyear, and another book that is, just let me show you, by Kenneth H. Rosen, Discrete Mathematics and its Applications by Kenneth H. Rosen. This is one book. Another book by that is E.G. Goodyear, Discrete Mathematics with Graph Theory, right, by E.G. Goodyear. Okay, so both are very good books. E.G. Goodyear and Michael M. Parmenter. So this is the that is textbook that is mentioned in your syllabus, right? So this is the first chapter, foundations. That is the logic, sets, and the foundation, right? So let us begin from there. Okay, so first of all, what do you mean by a proposition or statement? Okay, so proposition. So in some books it is also written as statement or statement in mathematical logic. So any sentence that we say and that is either true or false can be regarded as a proposition. Okay, say I say something like 2 is greater than 3. Okay, so this is a proposition, because this statement this statement is either true or false. Okay, so and not both, it cannot be both. So 2 is greater than 3, it's incorrect, right? So this statement is actually false, right? And say I write something like say x square is greater than 4 if x is greater than 2. Okay, this is also a statement, right? It is either true or false. X square will be greater than 4 if x is greater than 2. So if you are given that x is greater than 2, then can you conclude that x squared is greater than 4? Okay, so here it's true. If you take x greater than 2, x squared will be greater than 4. So this is also a statement. Okay, then say anything that is either say 2 plus 3 equal to 7. Okay, this is also a statement which says that the value of 2 plus 3 is equal to 7. Okay, but this is a false statement. Okay, this is a false statement, right? So in mathematical logic, we denote statements by these symbols P, Q, R, S. Okay, so the lowercase letters, that is the small letters. Okay, right? So if we have this, if we have a given statement P, we write the negation of P as this. That is, this is called the negation of P. Okay, negation of P. Okay, right? So what is the negation of 2 is greater than 3? It's just 2 is not greater than 3, right? In our usual language classes in school, we have already learned these things, right? 2 is greater than 3, it's the negative will be 2 is not greater than 3. Greater than 3, right? Okay, what will be the negation of this? So for this we will take some more time. Okay, this is a special sort of statement which falls under the category of implications. Okay, so we will take some more time to discuss that. What is the negation of this? 2 plus 3 is equal to 7. The negation will be 2 plus 3 is not equal to 7. Okay. Right, this is the negation. So one thing that you can observe is, if a given statement is say false, 2 is greater than 3, this is false. Now you consider its negation, 2 is not greater than 3. This negation is actually true. Okay, if you see it nicely, the negation is actually true. 2 is greater than 3, that is false, but 2 is not greater than 3, that is correct, right? 2 plus 3 equal to 7, this is false, but its negation is true. 2 plus 3 is not equal to 7, that is true. Okay, right? So what is the relation between a sentence and its negation? Is if one of them is true, the other has to be false. Okay, because there are only two possibilities, right? A sentence cannot be true and false at the same time. Okay, so given any statement P, its negation will have the opposite truth value. Okay, so in any statements in mathematical logic have got two have got any one of these two truth values. Okay, these are called truth values. Truth values. So in computer science, usually these are denoted by 0 and 1. Okay, so these are the truth values. So any statement in mathematics or mathematical logic will be either true or false. Okay, here let me go to the second page here. So then you have something. So we have something called the truth table. Okay. So truth table, it gives us a visual representation of the truth values of various types of statements. Okay, that can be constructed from given statements. Okay, so truth values for negation of a statement. Okay, truth table for negation of a statement. Okay, negation. So how do you construct truth table? You draw a table of this type. Okay, I can draw it nicely here. Okay, so I have this, okay, and this, and this. So I want to compare the truth table, truth values of P and its negation. Okay, negation of P, or it is also said not P. Okay, so P can take two values, either true or false. Okay, this is a mathematical statement or proposition. It can be either true or false. Okay, so if P is true, then negation of P has to be false. If P is false, negation of P has to be true. Okay, you have done these things in HS first year mathematical logic. Okay, so this is the truth table for negation of a mathematical statement. Okay, then we have if you have two different statements, how do you connect them together? Okay, so very often we hear something like this. Say say I want a phone that has say 8 GB RAM, okay, and say 64 megapixels camera. Okay, so what I want a phone that has 8 GB RAM and 64 megapixel camera. Okay, so this is not a statement actually. You cannot answer it in it is not means you cannot say whether it's true or false or not. Okay, it's just a sentence you can say. So what I'm trying to stress is this and. Okay, so we are connecting two different conditions together. I want something with 8 GB RAM and 64 megapixel camera. So if you give me something a phone with 6 GB RAM and 64 megapixel camera, am I satisfied or will it serve my purpose? That is, it will not serve my purpose because I want both the features to be in the phone. Okay, so if somebody gives me 6 GB RAM and 64 megapixel camera, I will say that no, it's okay that 64 megapixel camera is okay, but I want something with 6 GB RAM. Okay, 8 GB RAM. So I will not take your phone. Okay, so what I am trying to focus is this and. Okay, if you have two statements, say P, Q. Okay, if you have two statements P, Q, and you connect them using this and. Okay, P and Q. So this forms a new statement. Okay, say for example, 2 is greater than 3. This is one statement. Okay, this is one statement. Another statement is say 5 is less than 5 is less than 8. Okay, these two are separately their statements. 2 is greater than 3. This statement is false, right? And 5 is less than 2. This statement is true. Okay, I want to connect these two statements together. So if I write 2 greater than 3 and 5 is greater than less than 8, what will be the truth value of the combined or compound statement? Okay, this type of statements is called compound statement. A statement that is formed by say joining several statements using this connectives. Okay, and or okay, this type of things. So this and is also called it is also called conjunction, right? Conjunction. Okay, just let me get it verified. I get confused between these two, conjunction and yeah. P and Q. Let P and Q be propositions. The proposition P and Q denoted by P. This is the symbol inverted V. Okay, P and Q is the proposition that is true when both P and Q are true and false otherwise. Okay, so this is what I am saying. P and Q. Okay, so the statement P and Q, that is conjunction, right? Conjunction of two statements. Okay, conjunction is let P and Q be two statements. Okay, then the statement P and Q. Okay, symbolically we write it as this P and Q. Okay, this is what we write. Okay, this is the symbol. P and Q is the proposition that is true when both P and Q are true and false otherwise. Okay, the proposition P and Q is called the conjunction of P and Q. Okay, that is the thing. So the statement P and Q is true when both, pardon me for the handwriting, it's difficult to write in electronic writing pad. So when both P and Q are true and false otherwise. Okay, if any one of them is false, it's false, and false otherwise. Okay, otherwise, right? So what is the truth table? We say truth table of this conjunction. Truth table. Okay, so as you watch this video, please open your please take a pen and paper or your copy and try to write the things yourself. Okay, just watching this video like a movie will not help. Okay, mathematics, you have to do mathematics, otherwise you cannot learn. Okay, so this is the, so let me construct one table. So I need the values of p, q, and then I'll need the value of p and q here. Okay, so we have p, then we have q, and then we have p and q. Okay, so when both of them are false, okay, when one of them is false, okay, p is false, q is true, and p is true, q is false. Okay, and another case is both p and q are true. Okay, right, each of p and q can take two values, so p and q can simultaneously take how many values? 4 values. So that is the fundamental or the multiplication rule of counting. Okay, p can take two values, q can take two values, so p and q together they can take 2 into 2, that is 4 values. Okay, this is what, right? Clear? So I don't need this part, just for understanding. Okay, so if p and q are both false, then p and q will be false. If p is false, q is true, then also p and q is false. Okay, because I am not satisfied with one of them, right? I need that both has to be true. Okay, only then I can say p and q is true. P and q is true. Okay, so that means both have to be true, right? True, if p is true, q is false, then also it's false. If both are true, only then it is true. Okay, so this is the truth table for the conjunction, right? Conjunction of p and q. Okay. Next is another very important thing. So for example, what is the truth value of this? Say 2 is greater than minus 1. This is one statement, and another statement is say 5 plus 7 equal to 9. Okay, so this is one statement. What is this statement? 2 is greater than minus 1, that is true. Okay, 5 plus 7 equal to 9, this statement is false. So this and this, the truth value will be false. Okay, because one of them is false, so the truth value will be false. Okay, clear? Another statement, let me see, just simple statements. Say 2 cube equal to 8. Okay, this, and 3 plus 7 is less than 15. Okay, so this statement is true, this statement is also true, so this conjunction with this is also true, is also going to be true. Okay, so cube equal to 8 and 7, 3 plus 7 less than 5, 15, that is also true. Okay, so this is the example. Okay, then you have disjunction. Okay, disjunction. Okay, so this is the or connective. So let p and q be two. So this is the grammatical end now. Okay, let p and q be two statements. Okay, statements or propositions. Right, statements. Then p or q. Okay, this is the symbol. It is read as p or q. Okay, p or q is a statement. Yeah, that is true when one of p or q is true. Okay, only one of p or q is true. Right, sorry for that writing. So this is what, if you just consider this one, Let P and Q be proposition. The proposition P or Q is the proposition that is false when P and Q are both false and true otherwise. Okay, so that's a better way of writing. Let us write it this way. Okay, it's more clear that way. Let P and Q be two statements or propositions. Yeah, propositions. Then the proposition P or Q. Okay, P or Q. That is written as P, read as P or Q, is false when both P and Q are false. Q are false. Okay, and true otherwise. Okay. So when both of P and Q are false, only then it is false. Otherwise, it's always true. Okay. So what is the truth table? If you just want to construct the truth table, let me construct it this way. Okay, so we need P, we need Q, and we need P or Q. Okay, so how do you write? The truth table will be this. Sorry, P, Q, and this is P or Q. Okay, so let us start with false. So when both of them are false, P or Q is false. When one is true, one is false, another is true, it's true. When this is true, this is false, this is again true. When both are true, then also it's true. Okay, so this is the truth table for the disjunction. Okay, if you see the previous page, if I go to the previous page, yeah, this is the disjunction, this is the this is the conjunction. Okay, so if both of them are false, then it's false. If one of them is false, then also it's false. If both of them are true, only then it is true. P and Q. Okay, and this part is, if both of them are true, it is true. If one of them is true, then also it's true. And if both of them are false, then it is false. Okay, so it's very important to understand the truth table of this particular thing. Okay, so can you try to construct the truth table of, say this is one exercise, construct the truth table of negation of P or Q. Okay, negation of P or Q, and another one, negation of P and negation of Q. Okay, construct the truth table of this. Tables of this. Okay, so let us see what happens. So let us consider, let us draw two tables here. Okay, so this is for P, this is for Q. How many columns I need now? I need this 4 columns. Okay, right, one is for P, another is for Q, another is for P or Q, another is for negation of P or Q. Okay, and let me consider this also side by side. We will construct 2 different tables and see what happens. Okay, right, 1 P Q, and then I need the negation of this 2, right? Okay, so let us start. P Q. First one is I need P or Q. Okay, P or Q, and then I need negation of P or Q. Okay, so we start with say false, 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 true, true, false, and then true, true. Okay, so when both are false, this is false, right? What is the negation of P or Q? It will be true. Okay, if a statement is false or proposition is false, its negation will be true. This is what false, true, P or Q will be true, so the negation will be false. True and false, then the disjunction will be true, right? So the negation will be false. The disjunction is true here, the negation is false. Okay, so this is the negation of P or Q. Here in the second table I need P, Q, then I need negation of P, I need negation of Q. Okay, I need another column here. So let me make another column. Right, this is one column. Okay, and what is the heading? Heading here will be negation of P and negation of Q. Okay, this one. So let us start with this. If both are false, one is false, another is true, this is true, this is false, both are equal to true. So what is the negation of P? Negation of P will be true. P is false, negation of P will be true, this will be false, this will be false. Negation of Q, F is false, so negation of Q will be true, then Q is true, negation of Q will be false, then this will be true, this will be false. Okay, right, try to understand these things nicely. Okay, this may seem very simple, but gradually you will have to deal with more complicated truth tables. Okay, so now you find out the conjunction of these two. True, true, when both are true, only then it is true. In every other case it is false. Okay, so you compare this compare this column with this column. Okay, if you compare these two, you will see the truth values of negation of P or Q and negation of P and negation of Q, conjunction negation of Q, are the same. Okay, so can we conclude something about this? Okay, what does this mean, that their truth values are same? Okay, that is what you need to understand. Okay, so we will come back to that. So I'll give you a short exercise which you try to do. Construct the truth tables of negation of P and Q. Okay, and negation of P or negation of Q. Okay, try to construct the truth tables of this two, and then see, compare the last columns. Okay, what you see. So we will come back to this. So another thing that I want to discuss in today's lecture is the implication. Okay, implication. So very often we have something like this. Say if it is sunny, okay, then I will go out. Okay, I will go out. Okay, if it is sunny, then I'll go out. Okay, so this type of statements, right? Say very often you see in your childhood, your parents must have said, say if you score say 90%, then I will buy you a cycle. Okay, bicycle. right? If you score 90%, then I'll buy you a bicycle. Okay, yeah, my parents used to say. Okay, so this type of statements is called an implication. Okay, if you do this, then I'll do this. Okay, if this, then this, if this, then this. Okay, this type of statements are very often and encountered in mathematics. Okay, if a function f is differentiable at say a, then it is continuous at a. Okay, it is continuous at a. Okay, this type of statements you have already seen in mathematics, right? If x is greater than 2, then x square is greater than 4. Okay, this type of statements are actually called implications. Okay, and these are very important in mathematics. Okay, say if x belongs to real number, then x square plus 1 is never 0. Okay, this is also an implication, right? If x belongs to R, then x square is less than 0. This is also an implication. Okay, what is the difference between these two? So implication is also a statement. Okay, this statement is true, right? If x is a real number, then x square plus 1 cannot be 0, right? Because if x square plus 1 is 0, x square is minus 1, which is not possible. Okay, so this is a true implication, right? And what about this? If x belongs to R, then x square is negative. This is false. Square of a real number is not negative. Okay, so this is also an implication, but it's false. Okay, right? So implication has got two parts. So we can write this statement in another way. X belongs to real numbers implies that x square plus 1 is not equal to 0. Okay, we can use this symbol that is called implies. Okay, this symbol is called implies, right? Implies symbol. Okay, so it's a very common symbol which you have probably seen since your school days, class 5, 6, 7, 8. Okay, solving this type of equation, twice x plus 3 equal to 0. Okay, this implies that twice x equal to minus 3, then this implies that x equal to minus 3 by 2. Okay, this type of thing means if twice x plus 3 is 0, then twice x has to be minus 3. Okay, that is why this implication is given here, right? Okay, so so if you have a statement of this form, P implies Q, right? This is called an implication. The first statement here is called the hypothesis. Okay, the first statement here is called the hypothesis, and the second statement here is called the conclusion. Okay, conclusion, right? So for any implication, P implies Q, the first statement is called the hypothesis, the second statement is called the conclusion. Okay, clear? So if you consider this type of, so under what conditions the implication might be true or false? Okay, let us see. Okay, so let us go back to that statement. If you score 90%, more than 90%, say if you score greater than 90%, then I will buy you a cycle. Okay, so let us analyze this. Okay, so scoring 90%, so let us write it in a simple form. Score greater than 90% implies I buy a, or my dad buys a bicycle, buys a cycle. Okay, score greater than 90% implies my dad buys a cycle for me. Okay, for me, right? So, and let us analyze. So this is one statement, this is another statement. Okay, what happens if Suppose I have scored more than 90%. So this statement is true. Okay, so my dad will keep his promise. This statement is also true. My dad buys a bicycle. So the implication is true. If you score more than 90%, I'll buy a bicycle for you. So both are true. If P and Q both are true, the implication is true. Okay. Suppose I could not score 90%. Okay. I could not score 90%, but even then my father buys a bicycle. Right. I could not score 90%. I scored less than 90%, but even then the cycle is bought. Okay. In that case also the implication is actually true, right? In what case? To understand this, okay, we have to go a little bit further. Suppose I scored 90% but my father doesn't buy a bicycle. Okay, score is more than 90%, but even then the cycle was not bought. That means the implication here is incorrect. My father did not keep his promise. Okay. So if the first statement is true but the second statement is false, then the implication is false. Okay. Then the implication is false. Right. First statement is true, P is true, okay, but Q is false. Hypothesis is true but the conclusion is false. Okay. Then the implication will be regarded as false. That means this is incorrect. My father said that if you score more than 90%, I will buy you a bicycle, but he did not buy, even though I scored more than 90%. So he did not buy. That means this implication, that the statement that he made was incorrect, false. Okay. Right. Suppose I do not score 90% and my father doesn't buy the bicycle also. Okay. Then the implication cannot be regarded as false, because see, I did not score 90% and my father did not buy. Okay. So I cannot blame him. Why didn't you buy? Right. Just try to analyze this situation. Okay. Why P implies Q is considered true in this case also. Okay. In this case also it's considered true. Okay. And what about this case? I did not score more than 90%, but even then, suppose he was quite liberal. He said that yeah, you get a bicycle. Okay. Then also I cannot say the implication is false. Okay. Because the implication will be false if my father did not keep his promise. Right. So the implication in this case is also considered as true. Okay. The implication is true. So the implication will be false if the first statement is true but the second statement is false. Okay. P implies Q. So the statement P implies Q will be false, is false if P is true but Q is false. But Q is false. Okay. Right. So if only Q is false, and P is also false. If P is Q is false and P is also false, in that case, the implication is actually true. Okay. Right. I did not buy a cycle for you. Okay. So why means this does not violate my terms and condition. Okay, I did not buy a cycle for you. Why I did not buy? Because you could not score more than 90%. Okay, so you cannot say that I did not keep my promise. Okay, so if both are false, the implication is considered true. Okay, the implication is true. Means we cannot say we cannot reason why it's false. Okay. But if I did not buy a bicycle, even though you scored more than 90%, then immediately we can say that yeah, you were a liar. Okay, you did not buy, you did not keep your promise. Okay, so implication P implies Q will be false if P is true but Q is false. Hypothesis is true but the conclusion is false. Okay, So what is the truth table of implication? Truth table of implication will be this, right? So let us consider the truth table here. So this is one, P, Q, and then P implies Q. Okay, let us construct the truth table here. P, Q, and then P implies Q. Okay, so if this is false, this is false, this is false, this is true, this is true, this is false, and both are true. Okay, so when both are false, this is true. Hypothesis is false, but the conclusion is true. The implication is true. The hypothesis is true, but the conclusion is false. This is, in this case, it is false. Okay, and the hypothesis is true, and the conclusion is also true. In that case, also it's true. The implication is true. Okay, so the implication is false only when the hypothesis is true, but the conclusion is false. Okay, only in this case the implication is false. Okay, so let us see this here in this. In the implication P implies Q, the implication P implies Q is the proposition that is false when P is true and Q is false, and true otherwise. Okay, so in this implication P is called hypothesis or antecedent or premise, and Q is called the conclusion or consequence. Okay, so the truth table for the implication is this, TFT, right? So it is false only when hypothesis is true but the conclusion is false. Okay, right, and there are several ways of expressing the same thing, same implication, and these all those ways are very important. Okay, so let us see what is written here in Goodyear also about implication. Yeah, so many mathematical statements are implications, that is statements of the form P implies Q. So where P and Q are statements called respectively the hypothesis and conclusion. Okay, so say some examples. 2 is an even number implies 4 is an even number. Okay, so this is one implication. So implication often appear without the explicit use of the word implies. Okay, so without implies also we can write, just I have already discussed, if, using if we can write. Okay, so say this was what I was, if it is sunny tomorrow. Okay, statement under what condition an implication might be false. Okay, suppose your parents tell you, if it is sunny tomorrow, you may go swimming. So if it is sunny but you are not allowed to go swimming, then clearly your parents have something which have said something which is false. Okay, so that is what I was mentioning. If you score more than 90% and even then your parent doesn't buy your cycle, then the statement that he made is incorrect. Okay, however, if it rains tomorrow, okay, and you are not allowed to go to swimming, it would be unreasonable to accuse them of breaking their word. Okay, so this example illustrates an important principle. The implication P implies Q is false only when the hypothesis is true and the conclusion is false. Okay, in all other situations it is always true. Okay, so think about the implication. If 4 square equal to 16, then minus 1 square equal to 1. Is it true or false? Okay, so this is also an exercise for you. If 4 square equal to 16, if 4 square equal to 16, then minus 1 square equal to 1. Okay, this is true or false? So it's a statement of the type P implies Q. 4 square is 16, this is true. Minus 1 square equal to 1, this is also true. So this implication is true. P implies Q is true. Okay, say I give you another thing. Say if 2 is greater than 7, okay, then 5 is less than 8. Okay, so this is also an implication. So whether it is true or false, See, the first statement here is false, okay, but the second statement here is true. So hypothesis is false, but the conclusion is true, okay. So it's actually a true statement, okay. Okay, so so it may seem quite absurd that if 2 is greater than 7, there is no relation between these two, right? But the statement here is true, okay. The P implies Q is true. If 2 is greater than 7, this is a false statement, but this is a true statement. The conclusion is a true statement. So the implication will be regarded as true, okay, right? If 2 is greater than 7, then 5 is greater than 8, okay. This implication is also will also be true, even though these two statements are false actually, right? The first statement is false, second statement is also false, okay. So but the implication will be true, because the implication is false only when the hypothesis is true but the conclusion is false, okay. So with that, I will end here, and we will discuss this in the next video.